Lila is in Egypt on an exchange program sponsored by her school. Everything about Egypt is magnificent, and the pyramids that the Egyptians built around 2500 BC are just mesmerizing. It looks like the Egyptians knew a lot about geometry. How else could they have made such huge similar structures? What amazes her most is the similarity between the pyramids. Now, look at the lateral surfaces of all the pyramids. They are all triangles that are similar to each other. Welcome to the lesson on the criteria for the similarity of triangles. At the end of this lesson, you will be able to prove the AAA, the SSS, and the SAS similarity criterion of triangles. Let's consider two triangles, triangle ABC and triangle DEF. These two triangles are similar. Recall that for two triangles to be similar, two conditions must be met. First, the corresponding angles of the two triangles must be equal. Second, the corresponding sides of the two triangles must be proportional. Now, to prove the similarity of triangles, do we need to prove both the conditions? Actually not. There are three criteria that define the similarity of triangles. These are the AAA, the SSS, and the SAS similarity criteria. Proving any of these criteria is enough to prove that two triangles are similar. Let's discuss these criteria in detail. By the AAA similarity criterion, if the corresponding angles of two triangles are equal, then their corresponding sides are proportional and the triangles are similar. Let's consider two triangles, triangle ABC and triangle PQR. Here angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. In order to prove that triangle ABC is similar to triangle PQR, by the AAA similarity criterion, we'll prove that the ratios of sides AB and PQ, AC and PR, and BC and QR are equal. To prove the criterion, we'll mark 2 points, L and M on PQ and PR respectively, such that PL is equal to AB and PM is equal to AC, and then we'll join LM. Now, let's consider triangle ABC and triangle PLM. In these two triangles, by construction, AB is equal to PL and AC is equal to PM. Also as given, angle BAC is equal to angle LPM. Therefore, by the SAS congruence rule, triangle ABC is congruent to triangle PLM. Now, let's consider angle B and angle L. These two angles are equal as their corresponding angles of congruent triangles. It is also given that angle B is also equal to angle Q. Hence, angle L is equal to angle Q. Now, let's consider LQ. Observe that it forms a transversal to LM and QR. Since angles L and Q form a pair of corresponding angles that are congruent, LM is parallel to QR. Next, let's consider sides PL and LQ and sides PM and MR. By the basic proportionality theorem, PL upon LQ is equal to PM upon MR. That means these sides are proportional. Now, let's take the reciprocal of this equation. Let's add 1 to both sides of the equation and simplify it. Here LQ plus PL is equal to PQ, and MR plus PM is equal to PR. Through construction, PQ and AB are in the same ratio as PR and AC. Now, let's take the reciprocal of this equation. We'll call this equation 1. Similarly, AB and PQ are in the same ratio as BC and QR. Let's call this equation 2. Equating 1 and 2, we get the ratio of AB and PQ equal to the ratio of AC and PR, which is equal to the ratio of BC and QR. Thus, we have proved both the conditions for the similarity of triangles. Hence, triangle ABC is similar to triangle PQR. We have proved that if the corresponding angles in two triangles are equal, then their corresponding sides are in the same ratio and the triangles are similar. This is the AAA similarity criterion. An important point to note is that when two corresponding angles of two triangles are equal, then the two triangles are similar. This is referred to as the AA similarity criterion. The converse of this theorem defines the second similarity criterion, the SSS similarity criterion. We'll discuss it next. By the SSS criterion, if the sides of one triangle are proportional to the sides of the other triangles, then their corresponding angles are equal and the triangles are similar. Let's consider two triangles, ABC and DEF. Here the ratios of the corresponding sides are equal. In order to prove that the two triangles are similar, we'll prove that the corresponding angles are equal. To prove this criterion, we'll mark 2 points, P and Q, on DE and DF respectively, such that DP is equal to AB and DQ is equal to AC, and we'll join PQ. Let's consider triangle ABC and triangle DEF. It is given that the ratio of AB and DE is equal to the ratio of AC and DF. Now, by construction, DP is equal to the side AB and side DQ is equal to the side AC. Taking the reciprocal, we can also write the equation as DE upon DP is equal to DF upon DQ. On subtracting 1 from both sides of the equation and simplifying, we get PE upon DP is equal to QF upon DQ. Now taking the reciprocals again, we get DP upon PE is equal to DQ upon QF. By applying the converse of the basic proportionality theorem, PQ is parallel to EF. Since PQ and EF are parallel, angle P is equal to angle E and angle Q is equal to angle F, as they form a pair of corresponding angles. Now, DP upon DE is equal to DQ upon DF, which is equal to PQ upon EF. This can also be written as AP upon DE is equal to AC upon DF, which is equal to PQ upon EF. But AB upon DE is equal to AC upon DF, which is equal to BC upon EF. Therefore, PQ upon EF is equal to BC upon EF. Hence, BC is equal to PQ. In triangles ABC and DPQ, by construction, AB is equal to DP and AC is equal to DQ. Therefore, we will be able to prove that BC is equal to PQ. Hence, triangle ABC and triangle DPQ are congruent by the SSS congruence rule. So now angle A is equal to angle D, angle B is equal to angle P, and angle C is equal to angle Q. Since angle P is equal to angle E and angle Q is equal to angle F, angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. Therefore, triangle ABC is similar to triangle DEF. We have proved that if the sides of one triangle are proportional to the sides of the other triangles, then their corresponding angles are equal and the triangles are similar. Thus, the SSS similarity criterion is proved. Next, we'll discuss the SAS similarity criterion. By the SAS similarity criterion, if one angle of a triangle is equal to one angle of the other triangle and the sides including these angles are proportional, then the triangles are similar. Let's consider two triangles ABC and DEF. Here it is given that angle A is equal to angle D and AB upon DE is equal to AC upon DF. We will prove that triangle ABC and triangle DEF are similar. Let's mark 2 points P and Q on DE and DF respectively, such that the side DP is equal to the side AB and side DQ is equal to the side AC, and we'll join PQ. It is given that the ratio of side AB and DE is equal to the ratio of side AC and DF. Since DP is equal to AB and DQ is equal to AC, this equation can also be written as DP upon DE is equal to DQ upon DF. Now, let's take the reciprocal of this equation. Next, DE can be written as the sum of DP and PE, and DF can be written as the sum of DQ and QF. On simplifying, we get. Now, taking reciprocals again, we get dP upon PE is equal to dQ and QF. By the converse of the basic proportionality theorem, PQ is parallel to EF. Since PQ and EF are parallel, angle P is equal to angle E, and angle Q is equal to angle F, because they are corresponding angles. Now consider triangle DPQ and triangle DEF. Since angle P is equal to angle E, and angle Q is equal to angle F, triangles DPQ and DEF are similar. Let's call this equation 1. In triangle ABC and DPQ, AB is equal to DP and AC is equal to DQ by construction. It is given that angle A is equal to angle D. Therefore, by the SAS congruence rule, triangle ABC and triangle DPQ are congruent. Let's call this equation 2. From equations 1 and 2, we get triangle ABC is similar to triangle DEF. You have reached the end of this section. Before moving on, let's review the key points covered. Two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio or are proportional. If in two triangles the corresponding angles are equal, then their corresponding sides are proportional and the triangles are similar. This criterion is referred to as the AAA, or the angle-angle-angle similarity criterion of triangles. If two corresponding angles of two triangles are equal, then the two triangles are similar. This is known as AA, or the angle-angle similarity criterion of triangles. If in two triangles, the sides of one triangle are proportional to the sides of the other triangle, then their corresponding angles are equal and the two triangles are similar. This criterion is referred to as the SSS, or the side-side-side similarity criterion of triangles. If one angle of a triangle is equal to one angle of the other triangle, and the sides including these angles are proportional, then the two triangles are similar. This criterion is referred to as the SAS, or the side-angle-side similarity criterion of triangles. Hope you enjoyed this learning experience.